Okay, so we're going to look at some different forms of graphing quadratics today. And in this lesson, you're going to see that quadratics, which we know are equations that graph to look like a parabola, right? And they always have the highest exponent of x squared. Okay, so we're going to have different forms of that equation. Generally, you'll see the standard form, right, where we have y equals a number and an x squared plus another number and an x plus a 6. But that's not the only way that this can be written. And as we learned, one of the ways to solve quadratics is to factor it. Well, the factored form of the equation, right, is the same equation as this. It's just written as its factors, okay? So this equation and this equation are actually the same equation, but they look different in what they see. And you might look at this and think, well, that's not a quadratic because it doesn't have an x squared in it. But when you actually think about what happens if I were to multiply out these binomials, right, this x times this x would eventually give me that x squared, and then it would be multiplied by 2, and so it would give me the 2x squared, right? And so this equation is literally this equation. It's just written in a different form. Kind of like how when you have fractions, you could have something like 1/2 is the same as 2/4, right? Or 2/4, because they're written in different ways, but they are equivalent to each other. And then you also have something called the vertex form. And again, math people don't make up cool names for things. This is called vertex form because I can literally see the vertex if I look at the numbers that are given to me here. And we'll talk about that in just a second, okay? So all I want you to do for right now is think about what you can identify from the different forms, okay? So for today, we're just going to focus on what is visible. So in the first one that I'm looking at, the standard form, there's good things about standard form, but there's a little disadvantage in some ways because there's not much that's visible to you, like just looking at it, except for the y-intercept, okay? And we know that that 6 at the end, right, just like in a linear equation, is my y-intercept. Okay, so that's one thing I know, right, is that 6 is going to be a point on my graph, and it's going to be right there. But other than that, right, the only other thing I can tell by looking at this equation is that it has a positive a value, right? The first number is positive, and so I know it's going to open up. But other than that, just from that, it's kind of hard to graph my equation. I have to do some other math in order to get there, right? And so standard form, although it has advantages, graphing from standard form is not always that easy. So factored form and vertex form give you some other options, right? When you see them in that form, there are some things you can do. So let's think about factored form, right? If I were to compare to standard form, what can I see in this equation? Well, remember the factors, right, are the x-intercepts or the zeros of my function. And so if I know that x plus 3 is a factor, remember, like x plus 3 is equal to 0, I can subtract 3 from both sides, and I know that x is equal to -3. So one of my factors, right, is -3, and so one of my x-intercepts is at -3. And then I also know, right? I also know that the other one is going to be the same thing, that if I subtract the 1 from both sides, I'll end up with x equals -1. So the other x-intercept is also going to be at on the negative side at -1. So now I have a little bit better picture from these two equations, which remember I told you are the same. I have some points, right? I have x-intercepts. I also have my y-intercept from here, right? But you might not see all three forms at one time, but on this day, I'm going to have you look at all three forms together and then piece together what you can about the equation, okay? So this one told me the x-intercepts. This one told me the y-intercept. Well, I still know the y-intercept, right? Okay, so I know my graph is going to look like this. Remembering that symmetry in an equation is always, in a quadratic, is always true. If I know there's a point at 6 over here, I know there's going to be a point at 6 over here too, because I know this is going to come down, there's going to be a vertex here, and then it's going to come back up, and at this point there's also going to be another point. So if you're using your sort of idea of what symmetrical is, right, I already know that in between these 2 points, right, my axis of symmetry is going to be right here, okay? I just don't know exactly where my vertex is, right? Now, there is a way to know that, but I'm going to stick with the easier way, which is looking at vertex form. Okay, there is a way to know that even from this, and I'll come back to it in a second, but I want to look at the vertex form first. Okay, so vertex form is this third form. And remember, we said that the vertex is these two numbers. But just like with the x plus 3 part and the x plus 1, this one is going to be at the 0, right? So x plus 2, I'm sorry, that doesn't look like a plus, right, equals 0. So my x is negative 2. Okay, it's going to be the opposite of what I see in here. And then this is the y part of it, right? So the negative 2 and negative 2 is going to be the x-intercept. So again, this is opposite because it's kind of the solution of that x plus 2 equals 0. Okay, it's the opposite. And this one stays the same. So this is the x, this is the y of my vertex, and I can pull those two numbers out and give myself the vertex. So I know my vertex is at negative 2, which is right here. Okay, and again, I know that on this graph it would be right there now, but I'm going to put all the pieces together, right? Here's my negative 2, here's my negative 1 and my negative 3, right? And then here's my 6, and on the opposite side, I know there's going to be a symmetrical point at 6, but on the other one step away from the x-intercept, right? One place away from the x-intercept. And so I can see that my parabola has those 5 points that go together. Now, this is where I want you to pay attention just a little bit, okay? So I told you before that the graph of this, you could figure it out at this point from factored form, okay? You could figure out that the vertex is 2 down from those x-intercepts, from those 2 points that are like this. If you look at this number 2, right? The 2 tells you kind of the distance there from that vertex to those first set of points, okay? So those first set of points up, it's kind of like your slope in some way, right? It's like I'm going 2 up, right, and 1 over, right? 2 up and 1 over in each direction. If that was a 3, my next points would be going 3 up and 1 over. If it was a 1, my next points would be going 1 up and 1 over. Okay, so you can help find those next 2 points, right, by looking just at that number 2 and saying, oh, if I am at my 2 x-intercepts, I can go down 2, right, go backwards and find where that was, right? Those two points that are on the x-axis right there, right? They're going to be just that far from that point, okay? So hopefully that helps you guys figure out where that's located. If not, again, vertex form is the way to go there. So with all 3 pieces, I was able to piece together what the equation looks like without even doing any math solving, right? Without using the formula to find the axis of symmetry. So on the second sheet that you guys are going to look at today, and I'll go just through really quick one example. You guys are given, okay, so we're going to use the forms of the quadratic equation to find all the parts, all right? So I gave you all 3 forms here. So remember, this is standard form. In standard form, I can see the y-intercept. Okay, this is factored form. In factored form, I can see the x-intercepts, right? They're going to be the opposite of what you see in here because you have to solve them each for 0, right? So my x is going to be at 4 and my x is going to be at negative 2. All right, so knowing that, right, I know I have an y-intercept at negative 8. 1, 2, 3, 4, 5, 6, 7, 8, okay? And then I know I have points at 4 and negative 2 on my x-axis, 4 and negative 2 on my x-axis. And then I know it's a positive graph, right? It's a positive graph because this is a positive 1, right, in front of it. So I know it's going to look something like this, right? But I just have to find my vertex. And so my vertex is, again, this vertex form, that third form that we just learned about. Okay, that's that third one we were looking at here, the vertex form. It's the opposite of the one in the parentheses, and you keep the second one. So this is opposite, it'll be a positive 1, and this one is staying, so it's a negative 9. So positive 1 and negative 9. If I go to positive 1 and negative 9, it's right there. Okay, and you can tell that that 1, right, was because this went up 1 from wherever I was, right? That 3-point vertex should look like this little triangle, and the distance of it is 1 if this number is 1. The distance of it was 2 in the last example we looked at. So we're going to go like this. There we have our sketch, okay? So the vertex was at 1, -9. The axis of symmetry, remember, just goes through your vertex. So that's our x equals 1, right, which is the x of our vertex. My zeros are my 4, 0, and -2, 0, right? That came from the 0 factored forms. And the y-intercept is 0, -8. And that's all I want you to put for this, okay? Normally I have you guys do a little domain and range, but I'm kind of skipping that for now, okay? So for right now, I just want you to pull those pieces of information to help you graph this, okay? So you should not have to use Desmos for this. You should be able to pull everything you need out of the graph. I'm sorry, out of the equation to make the graph. All right, let me know if you need help.